All right, in our last video of the Unit 5 here, we're going to be discussing, we're going to be turning our attention to triangles. We're actually going to be talking about something called the midsegment of a triangle. So let's take a look at the definition, how to create a midsegment and exactly what it is. If we take a look at this little, this piece of notes here that I have written down, we are going to create a line segment. And we're going to do that by joining the midpoints of two sides of the triangle. So let's take a look at what that might look like. If I take, let's take side BC, and let me mark, in my best estimate, the midpoint. Then I'll take side AB, and I'll mark in my best estimate the midpoint. So we're going to call this midpoint E. We'll call this midpoint D. If you connect those two midpoints and create that little line segment, that right there is called your midsegment. So let's make a little note here that that is our midsegment. So this is pretty much the definition right here. The midsegment is a line segment that joins the midpoints of two sides of the triangle. All right, and we see the line DE in blue there. Now there's two relationships between this midsegment and this third side AC that I have here that we need to write down. The first relationship is that DE, it obviously looks smaller than AC, it happens to be half the length. So we're going to say that the segment, or the midsegment, is half the length of the third side. And in this case, our third side is that side AC. So really that relationship is as simple as saying if AC was 8 centimeters long, DE, the midsegment, would be 4 centimeters long. So we have half the length. The other relationship talks about DE and AC. You also might be able to tell that they are parallel. So I'll just highlight that in green. Okay, so those two lines. So we're going to say that it is parallel to the third side. Now what is that going to help? How is that going to help us? Well, if I extend these green parallel lines out like that, right, AC and DE, the other sides of the triangle, let's take BC for example, you might notice act as sort of a transversal. That all of a sudden opens up things like alternate interior angles and the other type of angles that we're going to be more concerned with right here. So something like that and like that. Those angles, you should remember, are called corresponding angles. So we're just going to jot that down, that this second relationship will help us or get us congruent corresponding angles. And that obviously is going to come in real handy when we're solving problems with angles and midsegments. The next couple slides, we're going to take a look at some problems and how we can use these two relationships to help us solve some algebraic problems. So this first question that I have in the notes is a pretty typical midsegment question. It's got three parts, but if we take a look at the setup here, it's definitely specifying, it doesn't tell us that DE is a midsegment, but it definitely says that D is a midpoint, and it says E is a midpoint. So if I know that these two are midpoints, and I'm getting this line segment, I know it's a midsegment. So now those two relationships that we had come into play. So if we take a look at the given information, which is right here, we have DE at 4x minus 2. I'll just label that here, 4x minus 2. And we have AC at a length of 7x plus 1. And it tells us that angle BDE, which is right in there, is going to be 75 degrees. All right, so let's take a look at part A. Part A simply says find x. That's simple enough. All we have to do is find the relationship between the two given pieces. And from the first relationship that we wrote down in a previous slide, we know that the length of DE is half. This blue line is half the length of AC. So what we can do algebraically is double the midsegment, and that's the most common thing to do in these algebraic problems with midsegments, is to double the midsegment and set it equal to that third side, in this case AC. So there's the algebra. If you distribute the 2 and solve for x, you should get x equal to 5. That's some simple algebra right there. Part B says to actually now find the length of DE and AC. Well, that just involves plugging in. That's not a problem. DE, if I plug in the 4 times 5 minus 2, that gives me 18. And if I plug in for AC, that gives me 7 times 5 plus 1, which is 36. And again, the goal there is to just check out the nature of the lengths. We see here that DE is indeed half the length of AC. And that's the way it should work out, so that's kind of how we can check that our X value is correct. Part C tells us to find angle B, where is it, BAC, which is right here, but we're going to use that second relationship, the fact that the midsegment and the third side are parallel, because since we know angle BDE is 75, that means angle BAC has to be 75 because of congruent corresponding angles, which we kind of just talked about in the previous slide. All right, pretty straightforward problem there. So in example 2, what we have are, actually, if you can see, 3 midsegments. It tells us that M, R, and T are midpoints, and since they've all been connected, that means I know they're all midsegments. So what we've formed here, if I highlight the midsegments, we form like a little triangle made of midsegments inside the larger triangle. So let's just take a look at what they're asking us to find. First, just matching up the midsegment with its opposite side. So AB, that long side right here, that looks like it's going to be parallel to TR. So that's kind of just matching up the original side with its midsegment. AC is parallel to MR, and we have BC parallel to MT. Now they're going to give me some lengths of sides here. So let's see, they have AB as 22, this side right here. They have, let's get some different colors here. They have BC at 12, and let's get AC at 20. Okay, so let's just match up the midsegment. Well, first let's answer the question in part A. Part A says find the perimeter of ABC. Well, that's no problem, just basically adding up these sides. And if we add up 22, 12, and 20, we should get a perimeter of 54. Then it says find the perimeter of triangle MRT. Well, MRT is that triangle formed by the midsegments. So we basically have to just find the length of each midsegment, but that's pretty simple. Because if I have AC is 20, get the purple here, AC is 20, the midsegment that matches up with that is MR, so that's got to be half the length of 20, or 10. I can go around and match them all up. BC, right, is 12. The midsegment that matches up with that would be MT, so MT's got to be 6. And then the last one, probably figure it out by now, we have AB is 22, that matches up with TR, so that's going to be 11. So if we add up 6, 10, and 11, that's going to give us a perimeter of 27 for the triangle MRT. Part C says, how do the perimeters relate? Well, we should notice that the perimeter of the triangle MRT is half the perimeter of the triangle ABC. So that should make sense. All right, so let's just jot that down. Perimeter of triangle MRT is half of triangle ABC. So if each midsegment is half of its opposite side, it should make sense that the perimeter of that triangle created by midsegments is going to be half of the total perimeter. So I'm actually just going to do number 3 here with you, and this is kind of a direct relationship to the question we just talked about. We have a triangle here, ABC, and it gives us the different lengths, 10, 14, and 16, and it says find the perimeter of a triangle formed by connecting midpoints. So if I take midpoint, 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 and I take that triangle, that's the triangle they want me to find the perimeter of. We just discussed that if I create a triangle using midsegments, it'll end up being half the perimeter of the original triangle or larger triangle. So if I add up the 10 and the 14 and the 16, that's going to get me a perimeter of 40 for the large triangle. All I have to do is divide that by 2, which we looked at in the previous problem, and we get a perimeter of 20 for our triangle formed by connecting midsegments. All right, Rocky wanted to say goodbye, but he wanted to show you one of his best tricks before he went. You notice right there, got that little treat on his nose, and he's showing you how disciplined you should be in your homework right now. Okay, Rock. Oh, he didn't get it. All right. See you later. Rocky, come here. Sit down. Say goodbye.